Hi, everybody. Did everybody have their coffee, their cookies ready? Because everything in IT needs coffee, okay? Don't forget that. Okay. So for people on Zoom, I hope you can hear me clearly. Right? This is going to be a recorded session. So if you don't miss something, you can always check it on the YouTube channel. So with that, let me start saying welcome to another episode of So You Want to Be a Data Scientist, right? And the topic today is basically an introduction to Python. This is going to be a very basic setup. It's going to be a very basic theme. Okay, so my name is Didier Barradas, and I am part of the KAUST visualization core lab. As you can see here, I have several of my colleagues. We all have different skills and different expertise. I am part of the branch of the data science with my friend Abdul Rafoul Halimi, that he's going to do some workshops later about hands-on in AI for KAUST people. This one is actually open to in-kingdom people and you here in KAUST. So about KBL, well, we are part of the core labs institution, like you know, or if you don't know now, you know. And we have a wiki, which is available for people that is inside KAUST. There you can have access to the list of courses that we have and several other things that we offer, like booking rooms and so on and so forth. There is a tab of data science tools for you, for KAUST people. And we have also some products like the KAUST Visualization Core Lab YouTube channel that you should all know and love and like and subscribe, please. Because there we put these workshops there and several other things that also include like the data science onboarding session that we do for KAUST people and how to use IBEX and so on and so forth. Okay. So only people that is inside KAUST can access this website. So if you need to access it, you have to use a VPN. All right, so what is Python to start with? Okay, Python is not exactly what you expect in the sense that it's like a language. But, you know, like what's the best language in the world? What's the best language just to speak? For example, if I tell my friend from China, hey, you know, English is so easy, he will put a face like, no, it's not, man. And I know that because the idea and the sequence of the words is different and the whole concept of how you talk is different. The same applies for things like Python and C++. For example, I know from the little form stack that I sent to you that some of you know some other programs, like for example, Java or C++. So the difference in that one, or with those one, is very simple, as a matter of fact. While C++ and Java are basically programs that actually they try to do the best optimization of the computer time, Python is trying to optimize the human time. Why I say this? Because the human time is basically how you chat with the computer. While C++ and Java needs to be converted into a binary that talks directly to the machine. And this is why they are super fast and it's a different world. The thing with Python is very flexible and it's taking over the world just because it's kind of easy if you know how to speak English. But like I said, like learning how to speak a language doesn't really require that you know how people speak the language. You know, like really speaking a language means that you are inside some kind of country and you know the slang and stuff like that. Pretty much goes along that line. But it's kind of easy to install. It is also very old already. And because of that, it has a very large amount of people that use it. It's actually one of those that has a library for everything that you want. A library for whatever you are thinking. Chemistry, physics, text, whatever you want. Okay, and the other fact is like Python is named after Monty Python's Flying Circus, which is a British comedy. If you think British can do comedy, that's one example. Okay, So why would I want to learn Python in the first place, right? Why wouldn't you learn something more complex and fast like C++? Well, for example, it's very difficult to learn C++ from the ground up because it requires you to think already like a machine with a structure, with sentences, with everything. Python is more flexible about that. It's highly integrated with something that is called graphic user interface. And there are some that are very popular. Right now, the most popular one, I think, is VS Code, which is from Microsoft. It has a very good integration with, Microsoft Windows and makes your life easier. So that's pretty much two of the things that you have to take into account when learning Python. Installing things is also pretty straightforward and has been also very useful for developing things in data science. Okay, so one of the first things when I started learning, it was, okay, where do I start? And for me, it was a torture because actually I go to the lab and the first thing my friend told me is like, go there. This is the Python tutorial, the official one, right? But then I have to read through all of that. And because I'm not a computer scientist, I had less than half of the idea of what many of the words meant. But I went through it, I grew with that in my mind, and nobody told me that there was a GUI. So I basically was thrown into the pit without a rope of line to get out. Okay, so you can go there and spend a lot of time. You can also go and search for any other tutorial. There is like 1,000 tutorials. And for example, we have here one that one of our very students here in the university did. Konstantin went all his summer, he spent it basically compiling this. If you go to this website, you will find a very deep dive into what is Python and how you can basically go forward after this workshop, hopefully. All right. So another thing that can help you is precisely this intro course that is based in the Carpentries. The Carpentries is an association that provides training to everybody who wants to basically start their path into this kind of computer science skills. This material is going to be in the web. It's for you to read. You can go back, read it again. I will forget things for sure. I will not say all the things that I can say, but you can check all the material again, and then you can basically enhance what you will learn. And it's a self-case. You don't have to be here. You can record this if you want, but you can go back to the materials and you can start over if you understand. So the web page, I did send to you several links. So the web page is one of those links that is very important. And I will show it here. So you have this one, okay? Also for the people over there in Zoom. If you go all the way down here, and if you didn't install Python, you can actually use the class hub. You can click here, and it will send you to this page where you can start here at the beginning of course. This is for people in KAUST. If you didn't give me your GitHub account, you can click here in this thing that is called Binder. I don't know if you can see this in the Zoom. I hope you do. Yes. Okay. And then you go all the way down here and click in Binder. And then it will trigger basically a program that will start a virtual machine. Well, sort of. For the people that is outside KAUST, click here. This one is basically a copy of what you saw. If you click here, it will start also a virtual machine that can help you to start this course. I will be using the class hub. So I can start going over here in the course. I signed up with GitHub, which is a website. And now it will take a time, but it will start now. Okay. So back to this. There is all the things. Also, I forgot to mention, but in the web page, click in this part here that says curriculum. it will lead you then to the material of the carpentries. Okay? It's all there. And it should look like this, as a matter of fact, like this here. Well, Sumerian setup. You should have arrived to this website. Okay? That's the material that I was talking about that you can check anytime at any point, whenever you want, whatever you want to do with it. Okay. So while that's loading, I also want you to use something that is a collaborative note. Because we are a community and everybody here is learning, I need you to enter into this link here that is also in the website. So please do so. Everybody can join. Over there is called, you will find this path. This is called Etherpad. So in this path, if you want, you can enter whatever name you want. I will name myself Rick Hunter. That's it. But you can just stay on name if you want. If you are shy and you don't want to put anything, you just stay there. And then, whoop, you can start, please put in your name here, or I don't know, some kind of initials so I can identify you later, especially to keep count. Oops. I cannot get out of here for now. Well, anyway, chat. Here, there you go. Say hi to everyone. Hi, everyone. So we can put things here that you can all then access. Anything that you think that is important, you can put it there, copy paste there, comment it there. There will be people there for helping you or to be as confused as you, doesn't matter. But the point is that you have this material for later, whenever you want to check it out, okay? Like for example, I do want to know when do you prefer these kind of workshops? I'm not a morning person for these kind of things. I would like to have them more in the afternoon, but it's up to you, okay? Just vote. Okay. Going back again to what I want you to do. Also, please, if you have there, start your own virtual assistant, either Bard or ChatGPT. It would be nice that you have one window with that because it's a digital assistant. I am just one guy, but this artificial intelligence is there for you and you can check it and you can ask him and you can make it do things for you, like programming in Python. Okay, you just have to just give the right keywords and it will help you. Okay, so in that case, please also, whatever flavor you want. Do you want Bart? Use Bart. I like Bart. I like ChatGPT. I like Llama, everything. I like everything. But Bart is my preference. Okay. So with that, I should ask you, are you already with one terminal? Everybody has their Python up and running, like a terminal or something? Yes? Pretty much yes. Just let me check over there in the ether. Oops, not that one. Everything ready. And we will do it. Okay. So in this case, for example, I have come here to this class thinking that you probably have your Anaconda Navigator. If you install Anaconda Navigator, go to the menu and start one Jupyter Lab, that one. We're going to use that one. Why? Because it's more neat, it's better for these kind of things. It's already a GUI, a graphic user interface. And with that, it will start and it will look like this, sort of. Different flavors for you. But it will have already installed Python and then you can go and click there where it says Python notebook, which is pretty much what already is deployed here in this setting here. Okay, mine looks like this. I have my files here. I can click here for a terminal or here for a notebook, and then it will start a notebook. What I like about this is that I can travel through all the different folders with 2 clicks, just like you normally do in your Windows system. Okay, there is that. Let's start this. Okie dokie. Okay, so because you're going to be a data scientist, and you will, there is one thing that is going to be a very good tool, and that's the Jupyter Notebook. Now, when I started learning this, there was no Jupyter Notebook. As a matter of fact, they just started to do something that was called interactive Python. And now the evolution or the natural course of things was to do things simpler and more interactive. So now we have the Jupyter Notebooks. And those files end in .ipynb. So that is IPY is because it's interactive Python. And then they put a better layer that is the notebook. And they're called notebooks because you can take basically notes there. You can save it and you can play with it in order to do prototypes of your scripts. Meaning that you can fail whatever, anytime you want, and a very specific part, which is nice. When you have a part that is failing constantly, you can debug it, you can fix it, and it will start running. Okie dokie. All right. So with that said, let me see. Did you already downloaded the data? Supposed to be SW Python, and then you have to do a folder with its name like that. Pretty much everybody has it. Raise your hand if you don't have it yet, so we can wait for you a little bit. Internet is not working. That's a very bad thing. Okay, that's okay, but don't worry. Try to download the material, and if not, we can check it out later. Okay. All right. So if you already have your folder done and you could download the setup, because it's actually here in this place. This is the website of the carpentries. You go over here and you have the setup page download is going to be here. You can obtain the materials here. You create a folder called SWC Python. And then you can enter here and you should have code and data folder. All right. So we're going to be in the data folder. And inside there, we can see already we have different files. And we can start one Jupyter Notebook over there. Here I am. Okay. So did you reach that part? Could you deploy the Jupyter Notebook? You're still failing with the internet. Well, the internet failed you. Okay. We wait a little bit. Everybody okay? All right. Yes, you can use Google Code Lab if you want. As long as internet doesn't fail you, you can use Google Code Lab. The same. Okay. I would like actually to rename this and put notebook 1 here. Okay. Now that I rename it, I want you to honor a very old tradition, older than the time of the dinosaurs, which is let's print hello world. Now, for Python and for pretty much all the different programming languages, there is some kind of option to print to the to the screen. And here, there's no brainer, is print, okay? The thing with Python is that all the things that we are going to call inbuilt functions, they are in between parentheses, okay? So print, you need 2 parentheses. Now, another thing that you have to do with Python is be very careful of what you write, because you cannot just write hello world like that. If you do that and you execute the file, it will tell you, what is this? When you're using print, you need to use quotes like this. And when you run it, there you have it. So if you go all over here, just do print quotes. It could be single quote or double quote. And that's basically a choice of style for you. Do you like single quotes? Do you like 1 quote, 2 quotes, 3 quotes? It's up to you, but be consistent. Once you get 1 quote for all the code. Do not mix, all right? So if you arrive to that, print hello world, that's pretty much basically your first program, okay? Were you able to print hello world? Hope so. Okay. So far, so good? Everything fine? Everything up and running? All right. Yes. Good. Good to know. Name it blue. All right. So as a matter of fact, in computer science, you're going to find different words that are going to confuse you. One of those are basically types. And here in Python, we're going to use only 3 types, which are basically the main types that you were going to need. One of those are strings. Strings means literally letters, all right? So for example, my string equals quotes, hello. This, when I do print my string, it will print hello. This is the way you basically input into Python what you want as a message, as a series of characters, okay? Always use quotes for that. Now, you can use Python as a calculator, right? Say 3 times 4, 12. And these numbers here I'll call integers. However, you can also do 3.5 times 4.5. And these, because it has decimals, are called float. So we just need these 3 for this lesson. You need strings, you need integers, and you need floating points. For those of you that already know how to program, probably you already know this and you're getting pretty bored. You can go get some cookies, no problem. It will be like 10 minutes like this for sure. Because I'm assuming that there's people that has pretty much 0 level of computing science. Okay, now, from here, we're going to say, all right, I can do mathematics like this. Fabulous, a super fancy calculator, nice. But what if I want to do something else, a little bit more complicated, right? What if I want to do this in another way? So we can start with a very usual thing, which is how do I store these values into Python? So for example, my operation, operation equals 3.5 times 4.5. So like you see, it's basic. It's something that everybody can understand. This is going to assign the result of that operation to something called my operation. Okay? The multiplication is very basic, yes. But this is called assigning a variable. Good question. What is a variable? Well, a variable basically is something that is going to be storing a value, a string, or a floating, doesn't matter. But what is very important is that it's very clear why what do I mean by that? If I do this and I just run the thing, it will say my operation. Okay. When I ask him, hey, what is my operation? Meaning that's okay, right? But if I do the same here and I change this by X, then X could be whatever, but it still is going to handle the same value. Now, my problem comes from the following. If I just say X, when I was in school, they taught me that X is a coordinate. I have an X axis and a Y axis. So if you just put X into a variable, it's not clear what it means, right? If like you are solving some temperature formula, you don't have to write just RT minus whatever number. You can literally put like the constant variable for, I don't know, constant pressure. Now, also, you could do something like, okay, this is the name of the result of my thesis volume 1 equals, I don't know, 3 times 5, like this. Now, this is also inefficient, right? It's over-explaining a thing. And as a matter of fact, it's just eating away my space. So it makes no sense to have something super long. You just have to be clear, not overly clear. But you can say just like, okay, let's do just value result multiply. And that's okay. You can do things very long. There was a time when the name was basically shortened because every bit and byte was meaningful. You have constraints. Now, what you have in front of you, if it's a normal computer from 5 years ago, is way more powerful than the computer that sent astronauts to the moon. And those had that constraint. This one doesn't. Okay? Now, with that in mind, you can start doing a lot of different things. Now, if you hear, here we have a lot of different data points. In this lesson, the carpentries put a very nice story. We have one so-called Dr. Maverick, and Dr. Maverick found the cure for some kind of inflammation problem, arthritis, and then he just put out one file, and that one file is this one that you see here, only the first 3 rows. But it means for each row you have a patient and each column is a day. All right. So Dr. Maverick is already claiming that he can charge, I don't know, $1,000 per time people use this medicine. Fine. Now, as a good data scientist, now is your turn to say if this is true or not. Okay. So once we have already done that, we can start. As you can see here, there is all the things that I was telling you about already. You can do this kind of very clear declarations of variables that will assign a value. You have our data types, integer, floating, and strings. Okay. And then I like this one. You can do some kind of things that are called concatenations. Now, those are string tricks. Okay. Say I have my string here. I can actually do something like my string plus world. WLD. Oh gosh, learn to type. Okay. And as you can see, it put together both things with no space. So I could actually do something like, okay, let's put a space here and check it out. And then you have a space. It's very easy to concatenate things in Python. as a matter of fact. You can use only the plus sign and it will be concatenated. You can save it into a new variable, let's say like my message equals this. And then you can print. Whoop, print my message. Now, I have concatenating stuff. One thing that I like about Jupyter Notebook is that Jupyter Notebook actually does a lot of things for you. What you saw just a moment ago is if you do open a parenthesis and you do double tap, things will appear there. There is a lot of things that can appear, but the most important part is that if you know what to type, it will help you to autocomplete. You see? Now here it's called I because this is an instance according to the computer people. But basically what it's doing is going over the different variables that I already declared. Jupyter Notebook is already opening a menu for me, which is nice because I don't have to reiterate every time that I want to do something. And then you complete the thing and you can print it. If you don't know what the thing is doing, you can always ask for help. Help, parentheses, print. And it will deploy a message that will help you to understand what is this thing doing. Okay. Jupyter Notebook is very powerful. And as a matter of fact, the autocompletion part is saving you a lot of times. It will tell you a lot of things. Okie dokie. Now, what I like about the notes on the carpentries is that it has these kind of things with a bell and some other that are like exercises. These are shortcuts to understand basically what's going on. Okay, so when you have time, you can read it. It will explain way better than I do what's a variable. Okie dokie. Let's see. Now, please go over the website and now do this kind of exercise. Okay, let's say what, 5 minutes, because this is basic. And I think you don't even need to write it down. If you don't know, there is always a solution. But first, try it. Try to do this exercise without seeing the solution. Okay? Everybody on the website? Okay, everybody is all the way to the bottom. If you have the website of the carpentries, it's all the way to the bottom. Okay, let me check. So for those of you that know another language, can you help me with this one? Can you write a snippet of another language? R could be good. What I want to see is if anybody can write like a C++ or a Java to declare an integer, to declare two strings, two floats. That would be a very handful and illustrating point. Thank you. There you go. Good, 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 good. Okay, pretty much everybody reached the 3 exercises. Okay, still working. Good, 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 good. Yes, you can use PyCharm if you want. Okay, I have to press run for each iteration. Nice. Okay, so to execute just one single cell, you can do Alt, Enter in each cell, and it will run that cell in a specific. Right? So for this one, for example, you can see here that when I press Alt Enter, it starts running and a new number on the cell appears, which is nice. It tells you where was the last time you execute something. You can see that I'm in love with Jupyter notebooks. They're great. Why is my kernel busy? It's a very good question. Should be executing something. Yes, it has an asterisk because it's running something. But that's as far as I can tell you what's your kernel doing. Okay. So one thing that, thank you, by the way, for those that already wrote a couple of examples there. Okay. So if you see here in the note, in the other path, different language have different ways to tell something. For example, in C++, you have to tell the machine where, what, and when you're going to use what. So if you declare something, let's say an integer, you have to tell already C++, hey, this is an integer. This is a double float. This is blah. And then it has to go all over the way. So in Python, this is different because as you see, if I want this number here to be assigned to a variable, let's say variable 1 equals 15, that's about it. I just put the number there, I press enter, and then that variable gets assigned that value. Okay? Even more cool than that, I can do it in one line. I don't need to do it in several lines, like for example in Java. Variable 2. And then you use one sign of equal, then comma, and then 3.5. And then I have two variables in one line. This is not usual for other languages. As a matter of fact, this is one of the powers of Python. You can do one thing in one line, very simple, very clear. And then you can start doing things like, okay, now that I have that, print, let's say, this number, then comma, and then variable 1 times variable 2, and it prints things. So in one line, and depending how you use it, print can do even the most basic operations, okay? It's very simple. This is why Python is called flexible. You don't need to over-specify things, it just runs. It's different than C++ in that regard. Okay? Consider, yeah, why not? There you go. Let's put this to sleep. Thank you, everybody, for that input. Yeah, the carpentries data is on the web page, by the way. All right, moving on. Now, let's go and analyze the patient data of Dr. Maverick. So Dr. Maverick already gave us something that's called inflammation 1 .csv. What CSV means is comma separated value. And this is what you're seeing in the bottom. There is like an array. As a matter of fact, we can check it here. Inflammation 1 is like this. Double click in inflammation 1, and Jupyter Notebook already knows it. So every column here and every row here is basically separated in a raw manner by a comma. Jupyter Notebook is intelligent enough just to tell you, okay, you can visualize it like this, but all these numbers are pretty much meaningless if you don't know how to interpret them, right? One of the things that we can do, we can start doing something using a very popular library. In computer science lingo, a library of things is basically a set of tools you can tell from Python, hey, import me here. Why? Because you don't want to reinvent the wheel. There are a lot of people that already have put a lot of effort, a lot of time to just do stuff for you. And then you just need to know where is that package of libraries that you need. One that is very popular is NumPy. So with NumPy, and to tell, hey, where are you going? To tell Python, hey, give me those tools here, you call import. That's the keyword, and you can see it's in green. And then NumPy. You execute it, and now NumPy is there. It's just that fast. Now, if you want to see what's inside, how do you input this into Python, this CSV thing? Well, you have it in this line. You can copy this line if you want. As a matter of fact, let's do it. Control copy, Control V. Boom. And you have exactly the same thing, right? Now, the Jupyter Notebook is not displaying all the numbers like we do in an Excel file. It's just going from one side to another and then dot, 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 because there are many values there. And then it will be a waste of time if you just have to go through all of them. It's just telling you, hey, I just put this here, and this is what I have. And it's now a type called array, because it's an array of numbers. You can check it out later in what means in computer science lingo. And we can do even better. We can save it. Now let's say file inflammation 1 equals that. And now here you are. You just save that into a new variable there. Okay, now you have it stored somewhere in the memory of the computer, and you can do things with it. Too fast or too slow? Maybe too fast for what I see. Okay, so let's go back a little bit. First, you import NumPy, which is a set of tools that you can use later to calculate other stuff. Now, what I just did was to load the information of inflammation into the memory of Python. Now, these that you see here, all these columns and this row, I am in the memory of the machine. And now we can manipulate it with Python. Good. Now, something that I like to do usually, or as a good practice of a data scientist, the first thing that you have to do is to test whatever you're doing with a small amount of data, something you can manage. Don't try to go all the way and try to process all the gigabytes that you have of information or data. Use a very small data set first to check if things work properly. And for that, you can start manipulating these kind of things. For example, there is something called slicing. And here you will see that the slicing goes this way. Like this, I think. Yep. Sort of. Nope. Of course. It's giving me error because I didn't write correctly the name of the variable. Now it's correct. Okay. Now, what I always remember is like if you want to slice things, you can put a comma there. This this 0.0 is the very first element of all the array, of all the list. It's basically this corner over here, this value. Now, to slice and dice things in Python, usually you use these square brackets. Then I always use the mnemotechnic MC because the first element is actually rows and the second is columns. So this one is rows and this is columns. You can use several of those, and we will see that all the way down here. Here, there you go. So say that you want to access a very specific thing inside of the file that you just loaded. You need a map to do that. And that's the map, pretty basic. You have the data, you have the file already that here. And now you can access it with a square bracket. And then you can go, okay, one column to column 0, or row 1, row 2, row 3, and so on and so forth. So in that case, if I want to access the second, it will be 1.0, 0. Also, that's a 0. But now I just went one row down. I can go one column, one row, and so on and so forth. This is the way you can navigate stuff one by one. And you can pretty much be interested in a set of numbers, not rather just one value, but you can do several values too. Those are accessed in this way. You just change the number here and you use column. So this column here in the position of the columns is just giving me this side over here. This is the patient 0 first 10 days. Okay? This is something that you have to master with practice, but always remember MC hammer. This is why I remember always like the first column is rows and the second is columns because MC, columns. Now, the column is important if you want a set of things. In this case, it goes from basically the first element all the way to the 10th element. But Python has a trick. As a matter of fact, Python counts from 0 to 9. In that case, what I'm telling this line is, okay, so give me all the elements starting from index 0, but exclude index 10. I know, it's confusing, but let's check it out. If we do just the first 5, you have here the first 5, right? That's pretty much about it. But the way Python understands it is like the last index he enters is the index 4, because this one is 0, 1, 2, 3, 4. This is how Python starts counting in everything. It starts from 0. And this comes because at some point, machines understand from 0 to 9, not from 1 to 10. I don't know why, but that's how you speak to machine. Okay? Machines are pretty stubborn. All right. So far, so good. We have a slice data. You can do this, for example. We can rename actually this thing to go with the examples here, data. And then, yes, let's just print this. And this will give you just a subset, which is the first 4 rows, and then the first 10 days. Okay? That's pretty much how you advance in this thing. And this is a good thing to subsample stuff. You can do a small data here, for example. This is what I like. Small, and you can assign it to a new thing. You run it, and small is, and you can recreate the exact sample of the cartridges, okay? This is a way of subset things which sometimes you have to do random, you have to do it sometimes just for the sake of being economic with the data. Good, good, good. So what we have been doing so far with print and with NumPy is to invoke functions. Some functions need input, just like I did here with the small data and with print. Some of them, like the example you see here with time, doesn't need that because time is kind of a constant thing, okay? There are some functions that work like that. In our case, we're going to use always something that needs an input, meaning that it's in between the parentheses. Well, we can start now with another part, which is going to be analyzing a little bit more of the data. But I think you need coffee. So how about a 5-minute break? Get some coffee, get some cookies, and we start over. Okay? Stretch a little bit. Give me
my computer, my traditional notebook. It like whenever I have this one, I also have this one, but it doesn't
lot of, how you load a file? Somebody already answered. Excellent. I know who answered. Data frames are easier. Yes, the data frames are actually in pandas. These, what we're doing with NumPy, are actually the same thing. Notebook, font, oh, sure. Big enough? Hope it's big enough. Okay. If somebody has this issue of not finding the inflammation CSV, just be sure that you are starting at a notebook here in this part here. Okay. Mine is not showing up there, but you have to go and start one here. As a matter of fact, like this. You have to have it here. My notebook is here already. Okay, discard. Yes, not found because of that. Exactly. You have to start your notebook here in the data folder. Okay, nice. Okay, let's continue expecting what Dr. Maverick has done. Okay, so far so good. Dr. Maverick has gone and said, okay, this trial is working. Nice. We can go and apply different statistics according to Python. And NumPy is precisely the best library that we have to do that. For example, let's do and copy this one here. You can see here, we're going to do some statistics. We are just getting the maximum value, the minimum value, and the standard deviation of that value of the whole data. Okay? In this case, data, as we define it over here, is the whole thing of inflammation 01. Okay? When you run that, you should get something like this. So what happened here is that we call something from inside NumPy. Okay? NumPy dot something will trigger a lot of things. You're actually interested in those ones that says I. Okay? So absolute, for example, has a lot of things to do. And let's see if this time help actually works. Okay, without this then. Okay. So everything that the Jupyter Notebook gives you with an I, that is an instance, is something inside NumPy that you can use. NumPy has a lot of things. For example, it has the maximum value, the minimum value, the absolute value, set score. It can give you pretty much everything of statistics you can think of. But there are other libraries that can do the same or even more advanced things. NumPy is just good because underlying NumPy, there is a C++ running that makes it even faster to process all numeral data. Okay. Now, in this case, we already did this, but this is a very good example visually of what we can do. We can ask Python to analyze, for example, just one patient. Okay. And that one patient only. If you slice the data, you can get the whole 40 days, as a matter of fact. And we can get it using NumPy axis equals 0. Now, oh, well, this is extensive. Okay. As a matter of fact, there are things here that are examples. That's nice. But going back into the topic, NumPy dot, let's say, mean data, and then you slice it and you say, okay, give me all give me all data in axis 1. This mean is going to go on the axis 1, which is all the rows. Axis 0, by the other hand, you do it, is all the columns. This is all the patients taken together. So far, we have reduced like several. As a matter of fact, let's check it out. Data.shape, because this is a NumPy thing, will give you these two numbers. And these two numbers mean, again, rows and columns. In this one, like you see in this depiction here, we went column by column. So this one here, if we do dot shape, corresponds to the 40 rows. As you can see here, you can do a lot of composite things inside Python, and especially for NumPy. If we do this here, shape, it should correspond to 60. And there it is. 60 columns, 40 patients. And we have reduced already all the data into one plot, basically, one set of lines. Now, I'm going to ask you to go again all the way to the bottom of the page and start doing these exercises of slicing, so you can get a better idea of what to do. For example, here you're going to slice basically strings. That's pretty cheap, and that's pretty nice too. Sometimes you want to slice the name of a file, because what you want is just to get all the things that are, I don't know, .csv. You want to eliminate that and rename it, or the first 6 or 5 characters, and then you just edit it. So please go ahead, go all the way down, and try to do these slicing exercises. If there is something that is not clear, please go forward or put it here in the Etherpad. Okay. Nice. Afternoon is winning. Okay. Hello. You can always do a little bit of cheating. Why not? What's the value of element colon 4? And what about element 4 colon? What's the, or element this column? Nice. Actually, this one is very useful. If you have, where am I scared to school brackets? All good, all the way down there, all the way to the back. Okay, I see some of you already finished. Okay. Okay, those of you that already finished the exercise can move forward. Okay. Yeah. This will be recorded and it will be shared in the YouTube channel. YouTube channel. Okay. How is it going? Good. Can I start the next session? Well, the next part or another 5 minutes. Okay. All right. So here comes one of my favorite parts. It's actually visualizing stuff. KVL, right? So here we have the visualization of one of the files, which is inflammation file 1. And according to our friend, Dr. Maverick, this is true. So in the first 10 days, there are still flare-ups. Then around day 10 to 20, there is a very bad case. And then the patient should start taking the medicine. And from day 20 to 30, the flares go down again. This is a temperature measure, right? Because according to Dr. Maverick, all the patients were taking the temperature every day. So far, from this point of view, you could say like, okay, seems true. It's just one file. It's 40 people in a clinical trial. All right. But you're a data scientist and you're more curious about that. So what I want you to do is to copy paste this part of the code and show it in your screen. Okay. So in this case, if we do this, oh, wait a minute. First, I have to do this. You have to do this. Yes. We start with this one so we can get the same thing. Okay. This is all our data set just in one picture that you can basically interpret. Now, the next one is this one. And you say, okay, let's take the average of everybody and plot it. And as you can see, pretty much tells the same story, right? It goes up, it goes down. Around 15 to 25, there is like a maximum temperature for everybody. Looks, everything is according to Dr. Maverick's tale. All right. You're a data scientist and you're more curious about that. Let's do something different. Instead of mean, let's do the max. And let's see. All right, something's funny here, right? If you're a human, pretty much your temperature goes linear. I mean, we're about 40 people in this room. Do you think our temperature is going to drop linearly? I know I will not because I'm fat, so I conserve more energy in me. But other people maybe will be dying of basically freezing. Okay, this is the maximum temperature. What about the minimum temperature? Do the same. Now instead of A max, do A mean. A mean. Now this is more curious, right? When you check everybody in this room, do you think we have like, I don't know, 10 people the same temperature for about the same days? Kind of funny, isn't it? Now, why don't we check the standard deviation? Let's check the standard deviation if we see something. All right. So who's good with standard deviation in this room? Pretty much everybody will be aware that a standard deviation of 4 is a very hard measure. You have a lot of errors. Kind of your PI wouldn't be like surprised that your experiment failed, right? It's like if you measure something 4 times, 10 times, and your standard deviation is 4, maybe you should repeat it, sort of. Okay, this is to exemplify very quickly that something is amiss, right? Now, if you want to present this to your PI, and because your PI is always very busy, and he needs 1 slide, you either have to copy paste one of these independently, or you can do just 1 block of figure and just present it 1 picture once and for all. And that's what I actually like to do. And this is what this block here does. And if you copy paste it here, you will have the 3 measures all the way showing in the front, right? Now, one thing that you should notice is that these figures have from 0 to 40 always, but the y-axis always varies. It is different. Sometimes that's not a good thing because it doesn't allow you to compare like really what's going on. In this case, because we're comparing the maximum versus the minimum, maybe leave it like that. Because if you change these values, the minimum will be just in the first part of the maximum value. Could be a good idea to stay like that, but it depends on you. Okay, so the next exercise are actually going to take you to that road. Like, how do you set things in this kind of plotting? Okay, so now you have another 10 minutes to go through these different exercises. While you do that, you can refill your cup of coffee because you probably need it at this point also. So feel free to go outside, take more coffee, go through this, and you will see how you can manipulate these images for the good. Do not manipulate images for just getting your approval, okay? Stick to the science. Can we compare the values if we normalize the values first? All right. We can compare the values, normalize it, yes, and they should actually share the same trend because the normalization is going to be from, I don't know, 0 to 1, and you can compare them later, for sure. Aru. But I mean, if you normalize the values, in theory, what you're doing is taking different tries from different parts. Yes. So for those of you that are actually familiar with R, there is something called ggplot in R, which makes absolutely amazing plots. The competitor in Python is called Seaborn, which is also very nice to plot stuff. And it plays very good along with NumPy and another library called Pandas. That's for future reference, because these plots, as you see here, pretty straightforward. They are just lines. You can set even the quality of the figure if you need it for publication or not, depending on you. And you can change colors. You can do that. You can do many other things. Depends on you what you want to do. Seaborn is as effective as this one, and in my opinion, it's more sophisticated and more pretty. Right. Meanwhile, I hope you are already in the verge of understanding what this chunk of code is doing, right? Here, you're already loading the data, correct? The second is just declaring, I need a figure, and it has some dimensions. These here are actually adding subplots to the figure. And remember, AMC, or well, you can come up with a better mnemotechnique and you can share it with me because MC Hammer is kind of old. But the thing is like, this is rows, this is columns, and this is the number you are assigned to that figure. This is why this is 1, 2, 3. There's only one row and there is 3 columns. And this is where you're going to place it. This one is going to be the first one, the second one, the third one. You can literally go over the same thing and invert them, and it will just switch them, okay? The third part of those are basically the order you want to display the figures. That's nice. And then you can set whatever you want as label. In this case, this is average. Oh, here. This is average, this is max, this is mean. And you can do the same thing for the x-axis. Okay, you can control whatever you want inside of your matplotlib figure. Takes a little bit of time, but at the end of the day, it's worth it because then you have a reproducible figure always, as long as you don't change the data, which you shouldn't. theory. Okay. Moving on. Well, can I move on? It's okay. Objections? None? All right. Moving on. Good. So how do you store things inside Python that are not the data that we have seen so far? There is another tool that you can use that is called list. Now, the lists are very simple, but they are very dynamic. Why? Because in data, if you type this, type data, you will see that it tells you, okay, this is a NumPy array. And that basically limits you to numbers. In NumPy arrays, you cannot input anything that is not a number. It has to be always a floating number. What if you want to basically associate three things differently? So for example, in my list, I can associate three things differently. My string, there to type. My string, then 3, and then, I know, 15.75. I give enter, and now if I try to deploy that, my list, there you go. It has inside a string, a number, and a floating number. Why is this important? Type my list, and that's a list. Okay, why is that important? Because turns out NumPy is actually only using numbers. What if you have something that is like a label, that is basically characters, and you want to associate it to a number, or to a sequence, or to a whatever? Then you need to use list. And lists can be very powerful just because they are that flexible. Okay? So this is why you want to use them. And how do you access them? It's pretty similar to what we already did. Because if we do something with squares, my list, square brackets, where are my square brackets? Okay. Zero. I got my string. If I go and do 1, I got a 3. So it's pretty similar to what we do with a NumPy. Indexes start at 0, and then you move 0, 1, 3, blah, 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 all the way to the end. Okay, so you can get basically what's inside of a list just the same way you did with NumPy. Now, the thing is, this is powerful because it's not only numbers, right? Now, if we do this and we say type, what here, then it calls an integer, right? Now, here, all the way here, is how to start doing changes. This is why it's called changes, like the music. All right, this was written for somebody older than me, so it was a song. Anyway, let's go all the way to here. What if you have a list of lists? Because, for example, in NumPy, you cannot have an array. Well, you can have an array of arrays, but it becomes terribly, terribly difficult. So if you do my list and you try to add it with append, it's basically my list. Okay, doesn't work. Now, as you see here, it appears some square brackets with 3 dots. What I just did was to add basically a list inside a list, and it becomes a list of lists. And this is why I want you to check on this kind of, on this picture here, because you have a grocery list where you have a list called veg, and you have your lettuces, your peppers, your zucchinis. If you want to access one of these rows, you can do it just like you did with a NumPy, but then it becomes something like this, because you can have a list of lists inside of a list. And then you can go and check and try to get one element of inside of the NumPy or inside of the list, just like you did with the NumPy array. As you can see, what you learn about NumPy is also applicable to the list. The only difference is that the list have that flexibility of just putting something that is not a number. Okay. Now, different to data, if I do something like my list times 2, what do you think will happen? It should, in theory, in our minds, it will duplicate everything that is inside, right? But it doesn't. Because what Python is understanding is like you want a duplicate of the list. So what you see here as a result is basically 2 times the same list. It didn't went element by element multiplying the thing. So this could be very confusing, especially for the computer, because what you want maybe is to duplicate one of the numbers, but you're actually just copy pasting the list next to it. So beware about this. It's not the same. To multiply things inside of a list is a different thing. Okay? So there is that. And for that one, then you have to learn how to append things. I mean, how to increase things inside of a list or how to take it out. I just showed you here that for a list, to increase something inside of the list, you use append, and then it will put it in the last element. And then to take the last element out, you need to do pop. Just without this. And then it regresses to the form it was before. Pop without anything. As a matter of fact, pop, what it does, it takes an index. And in the index, it takes basically out that element. Then when you check out the list again, now we don't have 2 of those things. You can pop things with the index and it will go and check that element, take it out. And if you did just pop, it will go over the last element and eliminate it. And so on and so forth. Now, if you want to enter something, like for example, my list, let's put it on the element 2 equals my MSG. It will tell you that it doesn't want to do that. Okay, this is different. Why? Because you have to append things in order to do that. Anyway, this is the basic. This is basically the 2 things that you want to do with lists. Usually you want to append something or eliminate something, but you can do also reverse things, like for example, over here. So if you declare this here, this list here, and then you put this into the reverse, my list now is equals to this. My list dot reverse. Just reverse like that. Doesn't want to do that. Okay, then print the reverse. None. I am doing something wrong. Okay, let's declare it. My list reverse equals. There you go. Print. Okay. None. Great. Live coding, everyone. Always something goes wrong. Anyway, this is one of the things that usually you can do with this thing, just reversing the order and so on and so forth. But with that, for example, you can also slice and dice things. From here, you can just basically drop all the way down to the next exercise. But is either that one or we continue. Depend, just chasing Dr. Mavericks. So let's go and take 5 minutes to refill your coffee because I feel that you need it. Why do you use A max and A mean? Is it the same with max and mean alone? You can actually type help and check it the difference now. Because yeah, the difference is in the details. The devil is in the details. So A mean and A max are basically for floating numbers and speed up the computation. It doesn't do a difference now with this data set. But if you grow the data set, then maybe you will need these kind of tricks. As now, because we have basic stuff, there is no difference. And at the end of the day, what you want is the result. So it depends on you. You can go with mean every time that you want. Okay, refill your coffee. Get some sugar if you want. Okay. what's the function of append? Okay, to include one element in the list at the end of the list. Hey, Hamut, can you put it in the Etherpad? Something appeared, so somebody's asking something. Yeah, that's okay. Could be in the Etherpad. All answers are welcome there. All right. All right, people, I still have 1 solid hours to go to 3 different things that I want you to take away. One is to go over things basically in a repetitive manner. The second one is to find things inside Python from outside. And the third one is basically choices, making choices. At the end, we should put the 3 together. But this one is a concept that I like to exemplify with 4. If you want to do something repetitive, you don't want to go line by line by line by line, right? Take, for example, if I have 5 numbers, I can do print, I don't know, 1, then print 3, print, blah, blah, blah. So you can do that for sure, unless you have like 10,000 numbers, right? You cannot do print 10,000 lines. Maybe you could, maybe you have the time, but that's not the point of learning this. To learn this, you want to do something like this in display. You want to do something that goes cyclically into something. So for that, you have here the example of odd number. You have a list over here that goes 1, 3, 7, 9, 11. You can do one print for each of these elements, correct? But that has 2 flaws. One, if you hard code it into your script, then you cannot change it. And once the value changes, maybe you break the script. And that's something that you don't want. Third one is like, it's going to consume your time very much. So what you can do is actually something called a for loop. And the idea behind the for loop is exemplified here. The machine will take your list and say, okay, this is my list from 1 to 11. Nice. You will declare for number in odds, which is this list here. The machine is going to go, okay, first element, now print. Once print, I haven't done the whole list. Go back, which is the number? 3. Now print that one, then the second iteration, and so on and so forth until he reaches 11. And it's something that you can basically write pretty quickly because it's for element in my range, for example, in my case, then print element. And there you have it. You don't have to write each time a print. Now, I want you to pay attention to 2 things. The first one, you need a semicolon, a colon at the end of range. This is telling Python, this is your order. This is where the for loop starts. The second one, we talk about this, the variable name. Be explicit. I just put there element in my range. I could put also, you know, X. Oh, space. And it will print something different. Now, why print 10 times 10? Well, this times 10. Because way before that, if you remember, I put X equals 10. So this is a problem. If I am not explicit on what I'm calling my variable, I'll just get into troubles in my script. So be clear and don't, you know, there is no budget cut in this thing. You can put very explicit things. Also, you can go nuts and say, okay, for banana, go back in my range. I can put this here. What? 2, 4, 6. Of course, it's element, no banana. And I just exemplify exactly why you have to be careful into naming things the same way here and here. So in this case, for example, I don't need to do this kind of thing here again. And I made 2 mistakes in a row. The first one was not to change the print statement. And I just left element. Element is still there. inside of the memory. And its value is 10. And I was just doing an error inherent to my own writing. Now, if you name the variable banana, is fine, but it doesn't serve you a purpose. It's not clear. Why banana? Why not temperature? Why not, I don't know, element is fine. But these things are the very little details that can make your life miserable sometimes. All right? So this is the way you loop over things and how you go about it. And here is the example with the banana. Now, you can do the same with all kind of lists. You have here a list of names, and you can do that. At the end of the day, you can get all the lists you want, go over it. You can go over the range. You can go over any NumPy array and go over it every single time. But be aware that you can take and make things like this that I just did. It will print element 10 times, and that's not what I want. I want to print a banana. Well, you know, an element of the list. In this case here, you can update this thing here. Now, that brings us to two different things. All right. So this brings us to two different things. Where do you place the variable? For example, in this example, the name is Rosalind. Every time you loop through the list of names, it will go and print a name. And it never printed Rosalind. Why? Now, the answer is very simple. The name here, the variable name, goes over this line here. And then after the loop, the last thing it remembers is that name was with the value of Turing. Name was Turing. So Rosalind never appears in the list because it was overwritten. Okay? Take care of these things, because where you put the variable is going to turn into a different value. So again, the little things that can make your life a living hell. Okay? Second thing, you can write several times a for loop, right? You can do this one here. Let's call it again element. Okay. And then you can go and say, okay, I don't want element. I want now this element plus 1. And then you have odd numbers. Still, element will be 10. But now what I'm doing here is just copy pasting my code. This is not a good practice. You can have things that are repetitive, but if you put once and over and over and over the same chunk every time, and you don't change the variable element, at some point you are going to have a problem. Just a given. You put this 50 times in a code, and if something goes awry, you don't know where that variable element is failing. All right? So you can go and change every time if you want the name. Now let's put plus 1. And the thing is like plus 1 here has to be the same. There is no limit for you to call or how to call things. Now, about variables. In Python, you can put variables with a underscore like this, and it works. But if you put a number in the front of the name of the variable, it's going to give you an error. You cannot use numbers like that in Python. Okay? Be aware that it's going to give you a problem. So usually in my style, for example, I always use strings and there is an underscore. And if you have an underscore after that, then it treats it different. Okay. So numbers before the name of the variable are going to give you trouble. After them, maybe not, but be aware that they have to be different every time you put a for loop, especially because problems can arise. All right. Now we can skip this because what I want, as a matter of fact, is to go back to this place here to analyzing multiple files. Because so far we have been working inside Python with one file and with our list. So the power of Python comes when you combine this stuff. Now, if we pressure Dr. Maverick, because he's a scientist and we need more data, then he turns to us and tells us, okay, so I have more trials now. I have up to 12 different trials, including the first one that I gave you. So he has been doing a lot of work. And now you have to check those 12 files. You can go about it one by one again. But what if you want to put everything together, right? What if you want to access all of them? Then is when you use something that is called glob or global, which is here. Okay. So this library here is one of the ways you can go about getting all the data that you have inside of the data folder. Okay. Very quickly, you can see it has brackets. It has the quotes, and then you have a list of all the things that are inflammation, something CSV. Glove allows you to actually go and check something that's called wildcards. The wildcards are here, question mark or asterisk, because you can do also this. Oh. All right. 0 question mark. Nothing. Inflammation. Here it is. There you go. So what's the difference between the asterisk and the question mark? Can you tell? Yes. I mean, the question mark just matches one character. The asterisk matches every character. Okay? So you can see here, we have all of them. It doesn't matter what is. And I just selected here just those one that have 0 some number. It could be also a character. But this is the way you capture your files into a list. As a matter of fact, you can clearly copy this and assign it over here. We can assign it to my files list. Okay. Now, if I want, let's say, the first element of this list, what do we do? Square brackets, 0.0, or 0, just 0. So my files, for example, here, there you go. And actually, yes, here it is. This is the first file inside of that list. Okay. Now, here is a challenge for you. Go over this list and load it into a NumPy variable. Just like we saw in the first part, build a for loop that goes over this list here, and then try to put NumPy to use to read each of these files. Aha, I see your faces like, what? Yes, you can do that. You have a list of files, but you haven't read the files. You just have the list of the names. Now, what I want you is to use NumPy to load the information into Python. And you don't have to save it. You just have to try to load it, make it work for you. Okay? Think about it. How do you build a for loop? And then you just call NumPy and tell it, hey, load this. Just load, nothing else. Okay. So the objective here is that you build a for loop, which we already seen that is very easy to build. And then use NumPy just to load the information of the list. Using glob, we already obtained a list of files. Now, you can iterate over that list of files, correct? And then I want you to load the information into NumPy. So let's check it out. The first part is basic, right? For inflammation file in my file list, then I can do, for example, print, just to check if inflammation file is going or iterating over it. Okay, fine, that's it. Step number one. I have all the names of the file one by one. The computer is going like, okay, for each element inside of my file list, I'm going to print one name. Nice. Okay. So, now how I load it into NumPy? Okay. So we can do NumPy dot load txt. There is fname. And in this case, the fname is inflammation file. Correct? Then delimiter. And it works. Okay. I have done no operation into the information. I just went over 12 different files in less than 1 second. And it just loaded into the memory as it going. Time. Come on, go down. There you go. Yeah. 10 milliseconds. Well, as a matter of fact, less than that. So is it humanly possible to go over 12 different files under 10 milliseconds? I mean, if you can, you're superhuman. Or supercomputer, who knows? Maybe the singularity is already here and Elon Musk succeed. So now that you have done that, you can even go further and say like, okay, let's assign this to, I don't know, data for inf, okay? Now there is that. And now we can start doing something like min, max, print. What was it? Data inf dot min. Is that okay? No, wait, it was not like that. It was numpy dot a max and then data for inf. And I'm doing all these very quickly because I press tab every time. So it's very easy. Tab here, in, tab. And again, data tab. And then again, numpy dot standard deviation, no stack, std. We open, we do data, select it, and there you go. One error, end of file. Thank you very much. You see, you're already good at Python. Where is it? Max over here, yes. Thank you for pointing that out. You're totally correct. I'm being lazy. There you go. So we can get all the information one by one, and you can start doing even more complicated things in the sense that, okay, these are just numbers. And it's going pretty much strange there, if you see that, because the maximum value is always 20. So there are something strange here in the data of Dr. Maverick, isn't it? Like really strange. But okay, we can go further than that, right? So now we can plot things. If you follow all the way up till now this part makes sense to you, isn't it? Now let's plot it. Copy paste this into your notebooks. Meanwhile, I will explain it. We have imported glob in order to access all the data that we have. Then we import NumPy because we want to do some kind of analysis, numeric analysis. We import matplotlib in order to get our figure. Then we get actually a sorted list of all the inflammation files. We are just going to get the first 3 files names, meaning inflammation 1, 2, and 3. Then we start a for loop. In that for loop, basically I have 3 files to go over with. For file name in those 3 files, I'm going to print that file name. Then I'm going to assign the name data to that data that I'm loading. I'm going to create one figure that is going to have 1 row, 3 columns, and in each of these positions, I'm going to get one different graph. And from that, I will get everything to show in one nice plot. So if we do this here, now we can see a very strange picture of what Dr. Maverick is doing. So even if you are not a biologist, you pretty much see something is off, correct? It's like, you know, the average of the first, the second, they look pretty much the same, but they're not incredible. The third one is the problem. It's like there were some days that somebody was pretty much, the temperature was very bad, like freezing dead. Then the maximum has this strange shape. And suddenly in the third one, we have noise and some variation. And then the last one, which is the minimum value, you can see there is like a step function there. Like there were literally people that were the same temperature every day, minimum. That's odd. Like I said, if we take as an example, this room, I'm freezing, but I know my core temperature is higher than other people that is slim. So the same happens in the second one. And well, this is becoming really odd because in the third example, everybody has a temperature basically of 0. Even if these are not human, that's a very odd plot. All right. So what do you think? Is Dr. Maverick correct? Is this data fine? What could be your best claim here? Even if you are like very, very, very good heart. Maybe somebody screwed up in the trials, right? But I'll give you another one. What if Dr. Maverick is so maverick that he's actually faking the data? Right? He's just desperate to get his clinical trial passed through the FDA and he wants to get the money. And it could be, because if you see this and you know a little bit about human temperature, this is quite odd, correct? So from that on, even if we see this plot here, which is the third one here, as a function of this, it looks like it could, like the first one. So this holds true still for Dr. Maverick. But if you go one by one, and if we analyze others, like if we change here from 3 to 6, then we start seeing something that is weird. It's still very weird. As a matter of fact, borderline a copy from the 6 to the 5. So there is something really wrong going on here, correct? Because you're a data scientist, this calls your attention very strongly. All right? So as you can see, here is how you use glove, NumPy, and for loops to go very quickly over, I don't know, tens, thousands, or I don't know, millions of files. It's very easy, and then you can do it. Now you can do it. And now at the end of this lesson, as a matter of fact, you will find that congratulations, you discover that Dr. Maverick has fabricated the clinical data. Because now you can push, right, for the right answers. Like, what is going on here, mate? This is not normal between two independent clinical trials. There are two different experiments with a set of different people, and you have a copy of that. Correct? So you got it. And then you just needed 3 things in Python: the glob, for, and NumPy. The beauty of science, right? Simply. Now, next to something that I really like, and pretty much everybody will correlate with me. So for my Arabic friends, what happened when your mother is very angry and they told you, inshallah? Yeah, right? It's like, I know when my mother was furious at me, it was like, maybe I should run, correct? Choices. Do you fight or do you flee? Pretty much what is this about, right? If my mother was very angry at me, I was just going to flee but you know, she had very good aim, so I couldn't go far away. But it's the same thing here. In Python, there are things that are called choices. We're going to explore something that's called if. There are other ways, yes. If is the more reliable one because it's very stable. So in this case, you have something that is called a Boolean. Boolean means basically yes or no, true or false, correct? So let's say that the input here is inshallah, and in here is mother angry. So if your mother is angry, you want to print run. If your mother is not angry, you want to print stay down, cool. And then of course, you can print pretty much survival or not. But this is behind the scenes, right? This is the way you have to think. What is something that you know almost for sure that something will happen? Then you can condition that inside of your script. And that's also what you have here. If you have a number and that number is greater than 100, then it will do something here. That's pretty much true for Python and true for every single one language of programming that you want to learn or to use. Conditionals are very good because they check your code, and pretty much you can do also divergent codes, taking basically a decision, right? However, there is something here that you should take into account. Where is your variable again? So in this case, if I do this, I can enter this part here just by changing this number. But okay, let's go slow down. What this code means here is that before the conditional, I have this number here. All right. Now num here. Okay. You see? Okay, this is a way to check if I did something with my statement. So before entering the if, you have a number. And if that variable already has assigned a 55 to that variable called number, if I enter the if, however, 101, is because this assessment of if the number is greater than 100 is true. Okay, this is as basic as it gets. It's true, and once it's true, it can get in. There are more things that you can do with it for sure, which is if else. So the structure of a conditional in this case is like, if something is true, if it's not true, okay, what else if? This is why elif is there. It's a shorten for else if. In other codes, you have to specify else if. In this one, it's just elif. So if the first condition is not met, then the code goes one level down and it explores, is this true or not? If it's still false, it defaults to else, whatever else is there. And then it prints that. Okay, like you can see here, the number is -3. So it goes into the first level. Okay, is number greater than 0? We know that for a fact that's not true. Then the number is not positive. It goes to the second. Okay, now it checks. Number is equal to 0 and it's false. So what is left? Else. So the number is negative. All right. But the true part that you have to probably memorize is this part here. So this part here is basically the operators. In the previous example, you saw that saying equals to is not the equal sign, it's actually equal. To compare things in a computer, you cannot write equal because equal is just a sign. So equals tells like, okay, compare these two things, and if they're identical, then it's true. And this is basically, these 5 here, these 6 here that you see here, are basically the conditions or the symbols that you can use. Greater than, less than, equal to, does not equal to, equal or greater than, and less or equal than. If you combine this in your code, then you can go and basically check things or do whatever you want, like for example, printing something or accessing some equation or the other equation. It depends on you. Wait. And then, for example, we can go still with the data that we have, that is from the inflammation. Now, we press here, this should work. There you go. So if you don't want to go like super quick about it, just like I did with this code over here. In this code here, I just spit numbers. There is no print something that tells me like, hey, there is something wrong here. I just did it by heart, just because things looks really, really similar. But what if I cannot tell it because it's in the 12th decimal place or something like that? A difference that is not very easy to see. Then you can use if statements. In this case, if the inflammation is basically equals to 0 and the max inflammation is again equals to 20 in one or the other file, because we are here accessing patient number, no, this one is, yes, patient number 20 and patient number 0, which are basically the first one and the last one. And then you check them and you say like, okay, those rows seems duplicate. As a matter of fact, there is data duplication inside. So this is very useful if you have data that is somehow noisy. If you want it to be noisy or is way outside of a range that you should know, then you can print some kind of message like this. Okay, and so on and so forth. For example, elif is always next to if, just because one cannot live without the other. But in this case, it just completed this here. So this was true, this gets ignored. It's okay. You can concatenate by different ifs. It's also allowed. There is nothing wrong with it. And you can just build your code like this with different markers that it will tell you if something is wrong or not. Okay? And of course, if everything else fails, you print an else. Now, if can be only by itself. There is no problem. Elif needs an if before it, and else needs an elif or if before it. So if is the best way to go about it. Usually is very straightforward, but you have more choices. In case you have like a range or something, then you can use the three of them. All right. With that one, you can copy this one over here. Wait, that's it, pretty much the same thing. Okay. So now you go about it, go all the way down to the web page. There is some exercise for you to do. Meanwhile, I'm going to check our friends from the Etherpad. Okay. Do glob stores the file random order? Yes, it does it. This is why you have to sort it. And it was shown in the code. Nice. Oh, no. I cannot see that one. Oh. I am adding PyCharm that. Okay. District of the 2% and time. That's actually something called Jupyter magic. It's inherit of Jupyter and it will not work in PyCharm. Well, this is because hello world. So this one here, even there is different things in Jupyter Magic. You could actually load a script that it was in another place. But that's a little bit outside of the scope of this. The point is that it will not work in PyCharm. Yes. It's only for Jupyter. Yeah. What? Unbalanced data. Yes, it could have been unbalanced data. If we go over here, very good observation. So in inflammation 3.0, all those waves that you see here, that could be either noise or imbalanced data. What it means that you have more numbers of the other, and then you see those peaks, but that's kind of unusual because this was all numbers. And they should have a range because they're supposed to be temperature. We will put this into the Etherpad. Yes, I know. Oh, question mark. Okay. hey, if you feel like, go and take some coffee. I know this is draining, so it's fair. Okay, ready for the last part? All right. So there's still a lot to explain after this one, but for example, this is the last one that I want you to take away from this. Why? I told you about that repetition of code is already a bad thing, right? So in Python, to avoid that, there is a thing that is called definitions. What does that mean? As a matter of fact, it means code I'm going to be using all the time, all right? It's very simple. The concept is that you have something in your code that you are just going to use, and you can well define what it is. So for example, this is a very good example. Okay. And this one is how to convert Fahrenheit to Celsius, which is fair, right? Some places on Earth, they don't like Celsius or the metric system. But then if you need to change every time your value to run a converter, you will end up with something like this, right? Fahrenheit, several times, over and over. So in this case, we can print here Celsius. And here, even worse, print Celsius val number 2. Remember my problem when I had this problem again? One of the problems was that Celsius val is start the same. I should change the ladder into Celsius val 2. Now, they are pretty close, so it's a very easy error to do. Now, the second one is like, this is not readable. At the end of the day, if I have to do this all over again, all the time, it's going to take me so much time, and somebody is going to come and read it, and it's going to be, why is this chunk again and again and again? And if something fails, where is the error? Sometimes, if you have 50 times this thing in a code, where did I misspell convert Fahrenheit to Celsius? So in order to avoid that, in Python, you have something that is called definitions. Now, here is the basic skeleton of a definition. You start with saying def for definition. Then you name your definition as whatever you want, but again, in the name comes many things. Put the thing very explicitly. What is this thing doing? Don't just write definition banana and it's converting Fahrenheit to Celsius, because it's just going to confuse people and yourself, okay? Second, it will have a parenthesis, because that is their input. This is where you're going to put things in order to work. And then comes the body, where you have an actual mini script. These definitions are nothing less than mini scripts that you need to use all over again. And finally, you can include it or not, the word return. The return is basically the keyword to say to Python, hey, give back this. And in that example, for example, excuse me, the redundancy. The thing is, like, in that example, you can already see that the operation of converting from Fahrenheit to Celsius is done in the same line. This is fine. You can do this. It's very concise. It's very, very thin. It's just 2 lines of code. Or you can be a little bit better and do some documentation. What does that mean? It means that if you use something like def var to cell, and then you have your parameters, temp1, temp2, maybe, and you have your columns, automatically you will have here your body. Do something. Okay, and then return. I don't know. Return that. we can take this to that equals this. Okay. So what you see here over this part here in the material is that you can use, wait, go back. You can use hashtag, or I don't know how the people call it. I call it cat. But anyway, people younger than me call it hashtag. And everything that has this symbol before it is take it as a comment. This is a comment. And because it's a comment, it's basically silent. So whenever you put this, it doesn't execute, right? So if you want some part of your code not to be executed, you can use this trick, and that's okay. And you can put as many as you want. Other comment. Okay. So I have to learn to spell start, but you can put many comments. Why are comments good? Because when you go back to your script, you will know what it's doing or what you were thinking at the moment. Think about it from the perspective of you're writing this for somebody else to use. That somebody else, most of the time, is yourself in the future. You know, so there will be times in like, I wrote this function. What is it doing? And maybe your state of mind in that moment was so caffeinated that you had a brilliant idea or you were just destroying your code. But at the end of the day, you have to put, what is this doing? Okay. Now, even better, you can put many different comments to work inside of the function. And that's okay. This is a step that you should take care of just because, and I say this by heart and by experience, you will sometimes not remember what you were doing. Especially if you start thinking about some equations that goes like, okay, temp equals this. And then you can return temp and that, and so on and so forth. The problem here is that if you don't put this kind of quotes inside, I mean, this kind of comments, you will not get a sense of what you were doing. You will get lost in your own code, and it's a very bad experience, believe me. So, is there another way to do this? As a matter of fact, there is. There is a thing that is even better than this. And it's curious because you have to do 3 of this and 3 of that. And you can get rid of this. In this way, using these 3 quotes, you're telling actually Python, look, this here is a comment, you know, inside of this thing. And actually, it's a message for you in the future. Like, this is what it's doing inside. It's equivalent to what we do in the other comment section. But if we do this here, like help, then it prints our message. With the previous one, we just silence it. It's a comment for you, for somebody who goes into the code. But if somebody wants to actually see what it's doing without needing to find where is your statement, you can do help, and then it will show that thing. Beautiful, as a matter of fact, because it's a message. You can put a poem if you want, but it's better if you put something that is more useful, like an example of how to use that one, right? And that's all the way down here. What? Where is it? Tie it up. Wow, way down. Way down. Wow, okay. Here, let's just find da. Here you go. I was wrong. So if we change this to here, for example, and we follow the same thing, then you can even offer somebody a guidance. And this is very pro, as a matter of fact. Like if you tell the people that is asking for help, this is an example how to use it, that's another level of pro in Python. I usually just leave it at, take care of this, this is doing that. But some people that they put actual examples, those are my heroes, because they know what they're doing. Okay? So definitions are pretty much simple in that sense, because you can put this here, and we can simplify this to temp. Now, there are elements that I want to highlight. For example, this one here can be whatever I want. This temp variable that I put here is actually amorphous. It's not a default. What does that mean? That means that it doesn't have a set value. What is that? That means that I can do this, and put something like data that I already did. And I need, for example, target value. Good. Let's put that here, over here. So in this part here, there are inputs. And your inputs should match whatever is going inside of your definition. Therefore, if you have something like this, then it works. As a matter of fact, Jupyter Notebook will know what you have defined as the inputs. Go down. Okay, let's do this like temp. Here it is. So I can define basically what's the name of the variable that I want to input. And then the Jupyter Notebook will know it, and I can match it. And in that matching, I can secure that my data is going to be in the right place at the right thing. Now, you can play with this for sure, because in target value, and here you can define whatever you want. You can do target value equals 0. And this is called a default. So this is a predetermined way of you saying this function is going to start like this. Unless you change it, it's going to be 0. All right? So in this case, if I do temp equals data, and then I say 1, then it works. Yeah, it doesn't. Here. Well, without this, it works. But then I have to specify target, and then it works. Okay? If I found something like this inside of a definition, I have to, by force, define it when I'm using it. Otherwise, it will throw an error. All right? So this one is basically the last part that you have to understand. You will do this exercise later if you want, but this avoids repetition of code. All right? Definitions are not very difficult. They are, think about it as mini scripts that you can reuse and reuse and reuse. And as you see here, it's pretty simple. You can put in the return what you want as a result. The input is whatever you want to have inside of that mini script to be processed. And that's about it. Once you get this into your script, you simplify a lot of lines. And it will help you also to troubleshooting your script. And that, my friends, is pretty much all that I can share with you today. Because 1, you run out of stamina. 2, we run out of time. And 3, pretty much you already follow what I've been told you about the basics. And with strong basics comes mastery. Okay? So if you have any question, any comment, anything, drop an email. You know my name now. So go ahead, go get more coffee because I see you need it. And that's it. So thank you for coming. Thank you for holding on. And let's see ourselves in another class, maybe later. All right. So off you go. Thank you, everybody. Bye.